Welcome everyone to Chorus One podcast. Today we have a very special episode about Stacks, which is a leading Bitcoin L2, which brings, amongst many other things, smart contract functionality to Bitcoin. And Andre Serrano was kind enough to join. He handles product and partnerships at the Stacks team. Welcome Andre, and thanks for joining.
Thanks, Luis. Happy to be here.
Awesome. Then, as we normally do, maybe we could would be lovely to start with an intro on your side. What has been kind of your crypto journey, and how did you end up in Stacks?
Yeah, sure thing. So I've been a Bitcoiner since early 2017, first as an investor, and also as an operator and contributor to several open source projects. Actually, previously I led business development at Zcash. So I've been interested in sort of zero knowledge and privacy preserving systems for a long time. And it was actually while I was there that I really started to explore how to apply these technologies to Bitcoin. And I came across Stacks in early 2019. And actually contributed to the Reg A sale at the time. And so I've been involved in the Stacks ecosystem for a while. I spent a couple of years at the Stacks Foundation. And now I'm actually the head of product at Bitcoin L2 Labs, which is a company in the Stacks ecosystem that's focused on core product research and development.
All right. Yeah. Super cool background. I didn't know you were an investor before Zcash. That's very cool, and cool to see kind of the evolution from that to a very interesting project. Maybe let's get right into it. Would be great if you could provide us with a high level overview of what is Stacks for those unfamiliar.
Yeah, totally. So Stacks is a Bitcoin layer. I think the goal is really to unlock programmability for Bitcoin by extending the functionality and new use cases of BTC, the asset, while also leveraging some of the unique properties of the Bitcoin network. And so the way that I think about the thesis is really just that when you look at the amount of Bitcoin that's locked in DeFi, the total value locked, it sits at around 600 million USD today. Not including protocols like Wrap Bitcoin, of course, but actually deployed in DeFi. Mm-hmm. And you compare that to, let's say, Ethereum, which has $48 billion of total value locked. And so, and that's, of course, despite being 3 times the size of the Ethereum network, right? And so when you look at it, there is just a blue ocean of opportunity for developers to start building Bitcoin applications. And I think that Stacks is just in a unique spot to capitalize on this, being one of the early movers in the space.
Yeah, so I think you touched on a very interesting comparison on kind of the sizes of the DeFi markets and so on. And obviously one of the main reasons or explanations has always been that Ethereum has native smart contracts, which enables quite a lot of use cases out of the box. Maybe since you're also very deep into the product side of things, it's fantastic to have you here. And if you could kind of guide us through why is it so challenging to build on Bitcoin compared to, let's say, Ethereum or others?
Yeah, so you're right. It has historically been very challenging to build decentralized applications on Bitcoin. I think that's why we've seen a lot of developers move to other ecosystems over the past several years, really prior to the rise of ordinals and more expressive capabilities on Bitcoin. And I think some of the challenges really are that Bitcoin has a very limited scripting language. And that's really been done by design to try to prioritize decentralization and censorship resistance at the Bitcoin base layer. I think another main challenge that I often hear from developers is just that Bitcoin has slow block times. And so with blocks coming in every 10 minutes, they're also variable. So it can take upwards of 20, 30 minutes at times. It makes it really hard to build certain types of applications that require a higher transaction latency. So it's difficult to build things like an AMM or a lending protocol if the execution price can vary by the time the transaction settles. And so I think some of those challenges make it really difficult, or have historically made it difficult, for developers to build apps on Bitcoin.
Yeah. So how does Stacks come in to attempt to solve this or improve at least the developer experience?
Yeah, sure. Well, I think that Stacks, especially with the upcoming Nakamoto upgrade, really allow you to move Bitcoin into DeFi to access more expressive smart contracts. So it provides developers with a much wider range of tools to build Bitcoin applications. And another feature is that developers will be able to benefit from much better transaction latency on the Stacks network. And so Stacks transactions will receive finality in an order of seconds as opposed to 10 minutes. And so I think both of these things together provide a much better user experience for developers to start building Bitcoin applications.
Yeah, I think that like you touch on the finality, which is something that I'd like to explore a bit further later on the proof of transfer, which is an innovation which that is very, very interesting as well. And yeah, something that we didn't mention is the VMs. For example, in Ethereum, you have EVM, which essentially it's a virtual machine that helps you on the execution of smart contracts and kind of setting rules and so on. In Stacks, you have Clarity. And this is like a programming language as well, but if you could like explain a bit further what it is and what's its purpose, that would be fantastic.
Yeah, absolutely. So Clarity is the virtual machine of Stacks and the smart contract language to deploy smart contracts on the Stacks network. A little bit of background about Clarity. So it is a decidable language, which means that developers can tell exactly what an application is going to do before it executes. It's also a Lisp-like language, which means that there may be a little bit more of a learning curve for developers to start building applications who aren't familiar with this specific syntax. But the feedback that we get is that once developers start learning Clarity, they tend to appreciate some of the unique features that it can bring there. We're also working on adding in additional runtimes. So it would enable developers to deploy smart contracts via WebAssembly. And so these smart contracts can be compiled to WASM. And so it would allow developers to deploy contracts in Rust or EVM. And so we're also excited about the possibility to start opening up programming Stack smart contracts in additional languages as well.
Okay, that's super exciting. I didn't know you guys were also working on WASM and all those implementations. I was actually going to ask about kind of the core differences between just using EVM and Solidity, for example, and why was this not done in the first place?
Yeah, I think that Stacks core developers early on realized some of the limitations of the EVM. And I think a lot of the design properties of Clarity were specifically tailored around security of the network. And so being able to write more decidable contracts, give developers a greater degree of confidence of what their application is going to do before it executes. It's also a human readable language, so it can be a little bit easier to audit the code. And so I think a lot of the design decisions of Clarity have been with security in mind.
Okay, nice. And now that you kind of, this is starting to be more implemented, you're starting now to explore other possibilities where you can include EVM or Rust or WASM or others, right?
Yes, exactly.
Yeah, that's very cool. I didn't know that, and yeah, we'll talk a bit later about kind of the developer landscape, but I'm sure that's also going to bring quite a lot of interesting new people who are used to building on EVM, for example. But we briefly mentioned the Stacks post Nakamoto upgrade. I think, like, for simplicity, let's stick to post Nakamoto. It would be great if you could also give us an overview of kind of the architecture on how does everything work, like proof of transfer. There's parties like signers, miners. In general, the architecture would be great to have an overview as well.
Yeah, sure. So at a high level, the Nakamoto upgrade is an improvement to the performance and security of the Stacks network. And so the way it works is that in proof of transfer, miners actually spend Bitcoin for the chance to win a Stacks tenure. And they will create multiple blocks within a single Bitcoin block. And this Bitcoin that miners are spending actually gets transferred to users who have locked their STX in consensus. In the Stacks ecosystem, we call them stackers. It's kind of a fun play on the word stakers. And so miners are proposing new blocks, which stackers must also validate and sign these transactions. So in some ways, I kind of think of it as like a hybrid network. But one of the unique features of this is that Stacks is the only protocol that is able to offer native Bitcoin yield as part of its consensus. And so when you're actually locking STX, you're receiving native Bitcoin as part of that. And we hear great things about that being a very sticky feature that users tend to like.
Yeah, absolutely. I was gonna actually touch upon that. I think there's a lot of Bitcoin L2s or economic layers, but normally the yield comes in another token, and Bitcoin is used as the stacking or staking asset. So I think the Stacks design was, for me, initially a bit hard to understand, but once you get it, it makes a lot of sense. And I think maybe if we were to walk through a transaction, correct me if I'm wrong, but kind of the miner, which is a Stacks miner, is not a Bitcoin miner, is kind of the block builder. The signer looks a bit more like the validator. And then the proof of transfer is where the Bitcoin miners bid some Bitcoin in order to be able to build the block. Is that more or less how it works?
Yeah, that's a great summary. It's not a perfect analogy, but in some ways you can think of miners as sequencers in a rollup who are building the blocks and ordering the transactions, and they send those transactions to the stackers who are signing and validating those transactions. And actually through that process, Stacks miners are actually sending an L1 Bitcoin transaction that records a record of all of the hashes, a hash of all of the Stacks block headers, so that anyone can essentially validate that those transactions have been processed correctly.
Okay, and the way the incentives work in the proof of transfer would be stackers get incentivized by Bitcoin and miners get incentivized by STX native token.
Yes, correct. Miners are receiving the STX Coinbase reward, as well as any additional transaction fees that occur on the network. And then, of course, signers are incentivized to fulfill those transactions through the BTC rewards that they are earning. And in terms of how the network actually works, I think it's also worth noting that Stacks is a typical account-based network. It's not a UTXO network. And so users would just generate a transaction. They process and sign the transaction, broadcast it to the network. Once that occurs, miners will pick up that transaction, process it, and include it into the next block. Okay,
and maybe on that point, when you say miners, you are referring to Stacks miners, correct?
Stacks miners, correct.
Okay, which will then eventually be settled on Bitcoin?
Yep, exactly.
Okay, so maybe that's a perfect next question. I think settling on Bitcoin is a very broad topic, and there's things like time stamping, which is pretty popular these days. But maybe you could guide us through why is it beneficial to settle transactions on Bitcoin, and maybe how does Stacks do it?
Yeah, so a key design goal of Stacks is to inherit some of the underlying security properties of Bitcoin. And so through proof of transfer, Stacks records a hash of all of the block headers of Stacks transactions to the L1. So all of this data is posted to Bitcoin, which means that anyone can verify that these transactions were executed correctly. And another, I think, interesting property here is that post Nakamoto, Stacks will always follow Bitcoin forks. And so this means that reorging a Stacks transaction will become as difficult as reorging a Bitcoin transaction. And so this is what we mean when we talk about the fact that Stacks will receive 100% of Bitcoin's economic finality, because these transactions are actually being posted to Bitcoin. And ultimately, since Stacks will always fork with Bitcoin, it's able to inherit much of the security benefits that users can expect from the L1.
Okay, and the idea would be that you kind of can go back to the Bitcoin state and recreate the Stacks state, and that's why it's kind of the 100% hash power that Stacks kind of claims. Is that
So
more or less correct? Or?
Close. Today in proof of transfer, it's possible to verify that all of these transactions are correct. You're not fully able to reconstruct the state of the network, but more so it's essentially a proof for correctness.
Okay, yeah, that makes sense, and I think it's essentially clear, and one of the missions or visions of Satoshi, I think, to use Bitcoin in this way. So yeah, I mean, I think maybe it would also be valuable to explore a bit more the token mechanics of the STX and BTC tokens. Like, if you could elaborate a bit further on how does this interaction work, and how essentially stacking or staking work as well within the kind of this proof of transfer mechanism. That would be great to expand a bit further.
Yeah, sure thing. So STX is the native gas token of the Stacks network. And so you need STX in order to pay for transaction fees. Although with Nakamoto, we are actually developing a way to abstract away much of that process through sponsored transactions. So that means that in a single transaction, wallets that support Stacks will be able to essentially swap sBTC for STX under the hood and abstract away anything that isn't specifically Bitcoin as part of that transaction. And I think the way that you can think about the design goal here is that we want to provide a Bitcoin native experience to our users. And so that means the ability to pay for transaction fees with sBTC. And so any of that additional complexity will be abstracted away from the user on the wallet side. sBTC will be the primary base pair on for transacting across decentralized exchanges, and it'll also be the unit of account for most transactions if you're buying an NFT or sending a payment somewhere. And so that's kind of the way that that STX and BTC interact with each other. STX is really the way to kind of make everything work under the hood and align the incentives as part of consensus, also being the gas token. And then sBTC is what unlocks this greater and more richer functionality for Bitcoin. Okay.
Yeah, I think that's also like helps like clarify, and maybe like to ask next about the stacking, which I think is something that changed a bit pre and post Nakamoto upgrade. So could you explain a bit further how does stacking work currently?
Yeah, so at a high level, users have the ability to lock STX as part of Stacks consensus, and when they do that, they must validate and sign Stacks blocks that are proposed by miners. Mm-hmm. And so for doing this work, they are compensated in the native Bitcoin as part of proof of transfer. And today, there's a few ways that a user can get started with stacking that are probably worth calling out. So the first would be, so I think one thing to note is that the minimum to participate in stacking, it varies, but it's typically around 100,000 STX per cycle. And there's a 2-week lockup period, which is the length of a proof of transfer cycle. And so if you are a solo stacker, you can, as long as you meet the capital requirements, you can participate in validating stacks blocks. And one of the other requirements to call out there is that all stackers will have to run a Bitcoin D node and a Stacks node, and basically keep the Stacks signer binary running that is essentially processing the logic for validating these transactions. So if you're a user and you didn't want to go through that, there are options available where if you don't have sort of a DevOps background or don't have the capital requirements, there are several pools that we work with that are set up for both institutional and retail Stacks holders. Chorus One, of course, is a great one that we work with that supports the Stacks network. There's also liquid stacking pools that are really a great way to basically participate in stacking while keeping your STX liquid. And so you're able to deposit STX, mint a staked STX token that is automatically accruing those rewards. Yeah.
Okay. And that's also makes things way more clear. And I think it's not a perfect analogy, but it ends up like for the average retail user ends up looking a bit more like delegated proof of stake, where you kind of can choose a validator, or there's kind of the liquid staking solution. I think stacking DAO is one of the solutions there, which would look a bit more like a Lido, for example.
Right.
But yeah, of course, with the differences of proof of transfer. Maybe one you also mentioned bridging, but before going into bridging and sBTC, I forgot about kind of the finality point. You mentioned that 2-week period. There's also something we didn't discuss, which are like kind of the micro blocks within the Bitcoin blocks of proof of transfer. If you could like explain this a bit further, how it works, maybe to relate it to how does Stacks increase speed and finality, that would be great also to explore a bit further.
Sure. So the concept of microblocks will actually no longer exist after the Nakamoto upgrade. So the way that it works today is basically that Stacks blocks are produced 1-to-1 with Bitcoin blocks. And so when a miner wins a Stacks block, they have the ability to create that block. After Nakamoto, a miner will actually get a Stacks tenure, where they're able to create multiple Stacks blocks within a single Bitcoin block. And so that's how we're able to increase the transaction latency for Stacks by essentially creating many blocks within a single Bitcoin block.
Okay, that's I didn't know that the microblocks thing was also changing. That's very, very helpful. So now like a miner kind of earns the tenure by doing the bidding with Bitcoin, and it enables the miner to propose a certain amount of blocks within the kind of 10-minute Bitcoin block time, right?
Yep, that's right.
Okay, so then that means that one miner proposes as many blocks. I'm not sure if there's like a definite number within one Bitcoin, and then every Bitcoin block, there's a new miner that bids and gets the spot.
Yep, that's correct.
Okay, perfect. That's also clear. Thanks for that. Cool. Then let's maybe go into bridging. I know there's the team is working on sBTC. which works a bit similarly, but also has differences. And Bitcoin bridging, of course, has been a long-standing challenge for many different projects. So there are many different centralized, decentralized solutions. So yeah, how does sBTC address the issue?
Yeah. So sBTC is a programmable Bitcoin asset that's always backed one-to-one with BTC. And it really addresses this issue of Bitcoin bridging by using a threshold network of signers to sign and validate Bitcoin transactions. So 70% of signers must agree to process deposit and withdrawal transactions and move Bitcoin in and out of the protocol. And it has some unique features that I think make it a really ideal Bitcoin bridge and improve upon previous bridge examples that we've seen. So the first is that signers earn BTC as part of this consensus mechanism to maintain the bridge. This is the mechanism that we spoke about previously as part of proof of transfer. And so earning BTC rewards as part of that incentive. And they're also posting STX collateral. So having a Bitcoin bridge that has collateral behind it, I think does help to address some of the security properties of the bridge. And also because sBTC will be integrated into the Stacks consensus, the protocol can do some interesting things with that, such as mandating that miners must include sBTC transactions. So this feature is called forced inclusion. It basically means that Stacks miners can't censor sBTC transactions. So I think that's another important security property of the system. And lastly, because of the finality rules that we talked about previously, we're able to offer faster deposit and withdrawal times for Bitcoin because we don't have to worry about Bitcoin forks. And so all of these features taken together, I think, provide a better user experience on the bridging side with faster peg in and peg out times. And with some security properties that I think improve upon sort of the current status quo of Bitcoin bridges.
Okay, yeah, that's very interesting. And maybe to elaborate a bit further, could you walk us through a transaction? How does the peg in, peg out work, and where does the 70% threshold? Where is it kind of important and has to occur? And then I think it's also very interesting if we can expand on the point you mentioned of miners not being able to censor the transactions.
Sure. Yeah. So it's a great question. So at a high level, a user would create an L1 Bitcoin transaction. This is a pay to taproot transaction. And from there, and that would deposit the Bitcoin into the sBTC protocol. From there, Stacks nodes are able to read Bitcoin blocks so they can detect that transaction has occurred. Again, because Stacks signers are running both Bitcoin D, a Bitcoin node, and a Stacks node. And from there, it requires a 70% threshold of signers to basically agree that transaction is valid. And so once you have a 70% threshold of signers that have signed off on the sBTC operation, sBTC would be minted on Stacks, in which point it can be used in DeFi and kind of get access to that full range of tooling that we talked about previously.
Okay, and the 70% threshold is not needed. It's only needed for this type of transaction. It's not needed for a transaction within the Stacks ecosystem, right?
So it actually is the same mechanism. So basically, in order to post new blocks onto Stacks, 70% of signers must agree that those blocks are valid. And so it's the same mechanism to basically approve an sBTC transaction.
Okay, perfect. That's clear. And then maybe lastly on that point, could you elaborate on the point you mentioned on miners not being able to kind of censor?
Yeah, it's basically because sBTC will be integrated into the Stacks core consensus mechanism. the protocol is able to mandate that signers must pick up sBTC transactions when they occur. So it helps to ensure that sBTC operations can't be censored, right? So you have a way to sort of mandate that miners are, including the deposit and withdrawal transactions into new blocks.
Okay. Yeah, that's clear now. Thanks so much for that. I think that was a very good technical overview. But yeah, then lastly,
could I add one more feature that I think it's worth kind of calling out as part of this?
Please.
So there's actually another feature that I'm excited about that's currently in development. It's called pay to contract call, pay to contract call, which basically means that you can deposit Bitcoin directly into a smart contract. And so we're looking at ways that we can reduce the number of steps it takes for a Bitcoin holder to basically take the action that they're trying to achieve on the Stacks network. And so basically what that means is that you can send a Bitcoin transaction, which will execute a smart contract on Stacks that can automatically issue a loan to access USDC or purchase an NFT on the Stacks network. And just by being able to have that really tight integration into Bitcoin, we're able to reduce the number of steps it takes for a user to do the action that they're trying to get. So I think it's a good example of ways that we're looking at how can we improve that user experience for someone that is going from Bitcoin and trying to access DeFi or some other application on the Stacks network.
Okay, yeah, that's very interesting, and this would work because signers are running nodes on kind of both sides. Yeah,
that's right.
Okay, so that would be kind of as you mentioned before, similar to the transaction you mentioned on the peg in, peg out, but essentially the signer also recognizes that there's a certain DeFi interaction that you can directly do just with a Bitcoin transaction.
Right, and you're depositing it directly to a smart contract, which that smart contract can execute immediately upon its receipt to do the action that you're trying to do as part of that.
Okay, yeah, that's very cool and a great piece of alpha. Cool. I think that's all the questions I had, kind of on the technical architecture and how things work. I think it was super insightful. And yeah, maybe to conclude, in the interest of time, if you could walk us through the developer landscape. At the start, you mentioned that you're also working on implementing EVM or other or Rust or other programming functionalities. I think that's super exciting. So yeah, curious on the current developer landscape. Is there anything that excites you and in general?
Yeah, definitely. So, at a high level on the Stacks developer landscape, we've consistently ranked in the top Bitcoin ecosystems according to the Electric Capital Developer Report, if not the top, I believe. And so there's certainly a robust developer ecosystem on Stacks. And I think a lot of developers are, excited, especially for this new bridging capability to be able to unlock a lot of this functionality around Bitcoin. And so, I'm really excited to start just on some of the core DeFi primitives that we'll be launching over the next couple of months as part of this. So as part of that, there's sort of use cases like lending and borrowing that I think are kind of like going to be the killer app initially for Bitcoin. And so, when you talk to users, people want to be able to borrow against their Bitcoin so that they can access fiat without incurring a taxable event, typically. So that they can either go, margin long and, increase their exposure to the ecosystem, or they just want to access fiat to pay for, a major life purchase, purchase a house without having to sell Bitcoin as part of it, or even just to sort of fund their day-to-day operations. So looking at lending and borrowing is a key part of that. There's a few projects that are working on this today. Zest protocol is a great example that is currently live, where you can access lending and borrowing. Currently, they support STX and staked STX, and I think a few other assets as well. So they'll be supporting sBTC on day one. There's some, there's several stablecoin projects on Stacks that I'm excited about. I won't go through them all, but one that I think is worth calling out that launched recently is called Hermetica. And so they're building a Bitcoin native stablecoin and yield protocol, which maintains the protocol through basically a covered call strategy. So it's very similar to Athena. And we know from talking to investors in the broader landscape, it's a very popular trade right now. And so being able to provide a more Bitcoin native experience for Bitcoin holders to access yield on their stable coins, I think is a great first use case. So you can imagine, that's like one user journey, if you will, right? Where a user deposits Bitcoin directly into Zest, that can automatically issue a stablecoin loan in one transaction, and the user could go and deploy those stablecoins for an average of 13% on Hermetica. And so when you look at that, and obviously that changes depending on market cycles, there's a range that they provide there, but I think the ability to access yield opportunities for Bitcoin and actually move Bitcoin from cold storage into something that is productive and able to actually deploy into DeFi is something that we're really excited about. So these are the types of applications that that'll be launching around sBTC, and we're excited to kind of help them mature and go into this next phase of development.
Yeah, that's super cool, and I think definitely a lot of exciting things to launch still. Maybe lastly, it just occurred to me, for example, having sBTC I'm curious about your thoughts on the developer landscape across the entire kind of Bitcoin ecosystem. Obviously, there's a lot of Bitcoin L2s or other names. Do you plan to have sBTC enabled for kind of the leading ones there? Do you plan to have some sort of interoperability here, or maybe you just plan to focus on just building on Stacks and develop the core ecosystem?
Yeah, it's a great question. I can say that we are talking with not only other Bitcoin L2s, but also other L1 protocols as well. And the idea being that because Stacks is able to offer Bitcoin Bridge with these sort of low set of trust assumptions, that sBTC can be in a position to really help to power DeFi in other ecosystems that haven't developed or don't want to develop their own bridge as part of that. So there's a lot of work that goes into that. Obviously, I think that looking at different canonical bridging options is really important. We're working with several bridge providers. I think Axelar was announced over the past couple of weeks that they'll be integrating Stacks into their amplifier network. With that, you can take sBTC, canonical sBTC implementations and use that across DeFi ecosystems and other chains. And so, we're doing that while we're also building up the sort of native core DeFi capabilities on Stacks. So, and I guess one last thing to add to that is that because of that pay to contract call functionality that I described earlier, it's one way to just reduce the friction that's involved in that, right? Because you can mint sBTC directly to Stacks, and then in the same transaction, maybe that can execute a bridge transaction that can mint sBTC, and sBTC will materialize in another ecosystem. So it's definitely something that we're looking at, and I think it could be a good growth opportunity for sBTC moving forward.
Absolutely, yeah. I think that's super exciting, and I do have a lot of questions, but for the interest of time, I think that's generally covered all the questions. So yeah, thanks so much. Not sure if you want to add some final thoughts on what's next for Stacks, but yeah, thank you so much for your time today.
Yeah, no, this was a lot of fun. The only thing that I'll add is, big shout out to Course One for supporting the Stacks network and being one of the signers that are securing both Stacks and sBTC. So it's great to be here chatting with you today, and looking forward to everything that's to come, especially as we go into end of this year, and into next year with all the developments that are happening across the Bitcoin ecosystem.
Absolutely. All right. Yeah. Thank you so much, Andre.
All right. Thanks, Luis.